So we're going to solve a couple of exercises on section 5.2. Like for example number 17, we want the region bounded by y equals 2 minus x, y equals 0 and x equals 0, and we want to rotate it first about the x-axis. First thing we have to do is to draw the region. Y equals 2 minus x, x equals 0 and y equals 0, this is the x-axis and the y-axis. Y equals 2 minus x, when x is equal to 0, y is equal to 2, and when x is equal to 2, y is equal to 0. It goes, this is the straight line. So the region between the three lines, y equal 2 minus x and the axes, is this region over here. What we want to do first is we want to rotate this around the x-axis. This is the x-axis, so we want to rotate it about the x-axis. First, we ask ourselves, is there any space between the region we are rotating and the line of revolution? No, so we will use discs, not washers. And in order to use discs, okay, this y equal 2 minus x, we need to represent one of the discs. So we draw a vertical line in our region, and we imagine that it has rotated about the x-axis. This is the disc it will form, and this is how the whole solid of revolution will look like if you imagine it. All right, it's like a cone. And what will happen now? We need to find what this r x is. Since we have x-axis, then everything should be dx, the functions should be functions of x, and the limits should be limits of x. The radius of this disk is always the distance from the line of revolution to the outside, which is all of this. How much is this r? It's y2 minus y1. So 2 minus x, the upper y, minus 0, which is the lower y. So it's 2 minus x. Then what will the volume be? V of x will be equal to the integral. The x goes from where to where? The x goes from 0 to 2 of, what is the area of one disk? Pi r squared dx. All right, we can integrate this by taking pi out, expanding, integrating one by one, substituting 2, 8 minus 8 plus 8 over 3 minus 0. So it becomes 8 over 3 pi cubic units. The same region they are saying in part B, they want to rotate it about the line y equals 3. So the same region that we had up there, which is this triangle, they want to rotate it about the line y equals 3, which is this line. It's a line parallel to the x-axis, which means it follows the same rules, which means dx functions are functions of x and limits are limits of x. And what kind of lines do we draw? Vertical lines. But here, if you look, you will notice that between the region that you are rotating and the line of revolution, this is the region you are rotating, and the line of revolution, which is here, we have a space, we have an empty space. This means that we do not use Washer's method, we do not use the discs method, we use Washer's method, because what kind of shape will we get when we rotate? When we rotate around this line, we will get a donut shape, not a disc shape. And because this is the case, to get the area of a donut and then integrate, so the idea is you get the area of one donut and you integrate it with respect to x. What's the area of a donut usually? It's the area of the outer circle minus the area of the inner circle. So it's pi r outer squared minus pi r inner squared. That's what the area of one donut is, or a ring, or whatever you want to call it. From where to where are these donuts going to happen? From 0 to 2. from x equals 0 to x equals 2. The idea now is to find the outer radius and the inner radius. As I told you in the explanation, to get radii, you are always going to start from the line of revolution. Always, you start from the line of revolution to the, isn't the segment, the vertical segment that you drew? You start from the line of revolution to the outside, this is your outer radius, to the inside, this is your inner radius. So what is the outer radius? The outer radius is y2, which is 3, minus y1, which is 0, so 3. The inner radius is y2, which is 3, minus the y value of a point on the straight line. What is the y value here? It's 2 minus x. You are careful to bracket so that you are doing it in the right way. This gives you 3 minus 2, 1 plus x. And then if you want to formulate the problem, it will be from 0 to 2, take pi common factor, outer radius squared minus inner radius squared. You integrate with respect to x. All right, let's look at another example. Let's look at number 20. The region bounded by y equal x squared and x equals y squared. Y equal x squared is this. X equals y squared is this. It's a parabola with respect to the x-axis, this part of the parabola. So this continues and this continues, but the region between them, so this is parabola y equal x squared and this is the parabola x equals y squared. But the region between them is this over here. This is what the region we are going to work with. First, they want to rotate it about the y-axis. To rotate it about the y-axis, this is the y-axis. What did we agree? Y-axis rotation, yani dy, yani x are functions of y. Limits are limits of y. And the lines that we draw are horizontal, not vertical lines. How does a horizontal line in our region look like? It looks like this. Is it stuck to the line of revolution? No, there's a space. If there's a space, yani washers. When it's washers, we need outer radius and inner radius. How do we form outer and inner radius? From the line of revolution to the outside, that's our outer. From the line of revolution to the inside, that's our inner. How much is it equal to? First, I need to change my functions into proper functions. How should my functions look like? X equal fy. Hey is okay, this is not okay. Y equal x squared, what does that mean? X equals root y. Now this becomes okay. You do not do the outer radius minus inner radius. You do not do this. You have to get the outer radius, all of this first, which is the x value here minus the x value here. This size, any horizontal segment has a length equal to x2 minus x1. x2 here is y, root y. x1 is on the y-axis, so it's 0, so the answer is root y. The inner is this piece only, from here to here. It has x2 on this function, which is y squared, minus x1, which is 0, so we get y squared. So Vy will be equal to pi taken as a common factor. The integral from where to y, where is this y going on? It's going from 0 to this point of intersection here. What is the point of intersection? How do I find it? I put y equal x squared. Yeah. So then the other function has x equals y squared. So you put x equals y squared, you get y should be equal to y squared, all of it squared, so y to the power 4. This means y to the power 4 minus y equals 0. So y into y cubed minus 1 equals 0. So they meet at 0 and they meet at 1. So this point is the point 1, 1. So from where to where will we integrate? We will integrate from y equals 0 to y equals 1. Pi, the outer radius squared, minus the inner radius squared dy. Be careful, it's not root y minus y, all of it squared. No, it's the outer radius alone squared minus the inner radius, which here it becomes pi. integral from 0 to 1 root y squared is y minus y to the power 4, and you integrate one by one to get the answer. The same region, now in part B, they are talking about the same region, which is this region. They want y equals, this is y equals x squared, this y equal root x, or x equals y squared, whichever. This y equals x squared. Alright, they want to rotate it about the line x equals 1. The line x equals 1 is this line. This is x equals 1. This is our new line of rotation now. What will we get when we rotate? Since this is parallel to the y-axis, it behaves the same way. So dy, limits of y, and functions should look like functions of y. So this is okay. And this has to be written as x equals root y for things to make sense. Alright. First I change them. Then the outer radius and the inner radius. Since a segment here will look like this. So there's a space between the line of revolution and the segment. The outer radius will be the whole thing. The inner radius will only be this piece. So the outer radius will be equal to the outer radius will be equal to, always right minus left. The right is 1 minus the left here is y squared. The inner radius is 1 minus the left here, which is this, is root y. So now the volume will be the integral by common factor, the integral from y equals 0 to 1 of the outer radius squared minus the inner radius squared dy. You expand each one of them and you integrate one by one. This is basically what I wanted to talk about section 5.2. The more you practice, the better you become. So make sure that you practice enough numbers of time over the whole